Welcome to Video 4, Graphical Representation of Experimental Data. In this video, we'll cover graphing your data, the importance of labeling your graph, what does an R value tell you, and which data points should you include in a linear regression. During your experiment, you'll be asked to record certain information. This will be very evident in your lab manual. This information can then be plotted on a graph, which serves as a powerful tool in analyzing your data. However, there's a couple of problems with this graph. Let me elaborate with a few examples. What if I told you that this graph represents the amount of snowfall in Aspen, Colorado between December and June? Let's take a closer look. That would mean that in December, roughly 20 feet of snow fell, but by June, only 1 to 2 feet of snow fell. Now suppose I told you that this graph represents the number of dunks per NBA player per season. Again, let's take a closer look. That means there's roughly 20 players with 1 or 2 dunks per season, whereas there's only 1 to 2 players with 200 dunks per season. Seems like a logical conclusion, but is this the correct interpretation of the data? In order to be able to interpret this data, we need things like labels on the axes and a title of the graph. Suppose now I tell you that the title of the graph is the freezing point of cyclohexane, and the x-axis is labeled time in seconds, and the y-axis is labeled temperature in degrees Celsius. Does that provide a bit more context into understanding what the graph is able to tell you? I would hope so. Let's have a look at an actual graph generated in the lab. Here you can see that the y equals mx plus b linear regression line was chosen for specific data points. Furthermore, you can see an m value, which corresponds to the slope of that linear regression line, and a correlation value, also known as your R value. The correlation value is a measure of how good your data fits the line. The closer this value is to either 1 or -1, the better the linear fit of your data. Poor experimental technique will result in poor data quality. This can be observed in nonlinear graphs and/or low R values, meaning that points of your data do not correspond to the rest of the data. When deciding which data points to include in your linear regression, it's important to consider what you're trying to demonstrate. For example, in this graph, we would want to include everything below the inflection point, indicating the freezing point of cyclohexane. In other experiments, you may be tasked to explain other instances, and it's important to consider exactly what you're trying to show in order to decide what to include. Thank you for watching Video 4. I hope you have a better understanding of the graphical representation of experimental data and just how important it is to consider what you will include in your linear regressions and to be sure to label all of your axes and graphs entirely.